Hello class, Mr. Sutton here, and today we're going to be talking about Skill 10, Discriminant. So what is the discriminant? The definition of the discriminant is a function of the coefficients of a polynomial equation whose value gives information about the roots of a polynomial. Specifically gives information whether the roots are real or imaginary, rational or irrational, equal or unequal. So those are the three pieces of information the discriminant gives you. So make sure you have this definition and the three types of information you can get. The discriminant formula is discriminant equals b squared minus 4ac, which might look familiar to you, and that is because it is taken out of the quadratic formula. Specifically, it's taken out of this part right here, this part underneath the radical, and because that is the important part of the quadratic formula that tells you what kind of roots you're going to have. So like our roots are the x value. Once we simplify everything, that's the roots we come up with. But depending on what's underneath this radical determines whether your solution is real or imaginary, rational or irrational, equal or unequal. So we're going to go through the different possible discriminants you can have and determine what that makes it real, imaginary, rational or irrational, equal or unequal. So I have a chart or a table for you to fill out. Make sure you copy this table down exactly like I have it and fill it in along with me. So we have 4 different types of discriminants. We have our discriminant is positive, greater than 0, meaning it's a positive value, and also a perfect square. So like 1, 4, 9, 16, 25, etc., etc. And then there's the discriminant is positive but not a perfect square. So like 2, 3, 5, 6, 7, right? All the numbers that aren't these numbers. Then we have the discriminant equals 0. And we have the discriminant is negative, less than 0. All right. So first, let's look at this first column where we have a discriminant that is positive and also a perfect square. So would that give us a real or imaginary root? That would be real. Rational or irrational root? That would be rational. Equal or unequal roots? These would be unequal. So what does that mean? Let's think of an example here where we have a discriminant that is a positive perfect square. So let's say we did the quadratic formula and we got -4 plus or minus square root of 36 over 2. So the discriminant in this case is 36, right? That's where b squared minus 4ac is in that formula. So that's positive. That is a perfect square. So when we simplify this and find our roots, the square root of 36 is 6. So we get -4 plus or minus 6 over 2. And we can simplify that even further. -4 divided by 2 is -4. Or excuse me, -2. -4 divided by -2 is -2. Plus or minus 6 divided by 2 is 3. So we have -2 plus 3, which is 1, and -2 minus 3, which is -5. So we have 2 different roots here. And they're both real numbers, right? 1 and -5 are real numbers. And they're both rational, they're integers, and they're unequal. 1 does not equal -5. And that'll be true for any quadratic you find where the discriminant is greater than 0 and a perfect square. So let's go ahead and look at the second column here. We have a positive discriminant, this time a non-perfect square. So these would also have real solutions, real roots. And this time they would be irrational because that square will not simplify. Irrational. And once again, we would have unequal roots. And one thing I want to clarify right now is that I'm using solutions and roots interchangeably here. So that's something to note. When you're talking about solving quadratics, the solutions are also called the roots. Those are interchangeable vocabulary for this, just to make that clear. So an example of one like this would be something like this. So if you did your quadratic formula and you get something like this in the end, the 41 here is the discriminant. It's positive and it's not a perfect square, so it's not going to simplify any further than that. So these are still real solutions, real numbers, but they are irrational. If you plug this into your calculator, you're going to get decimals that go on forever, so they are irrational. We can't simplify this to any integer, fraction, anything like that. And they're unequal because we have two different versions of this answer here. We have the plus version and the minus version. So two different answers here. And that will be true for any discriminant you get that is greater than 0 and not a perfect square. So let's go ahead and look at the third column here. This time the discriminant is equal to 0. So that would be real and rational. And this time we'd have equal roots. So example of that would be if you solved your quadratic formula and you simplified it and you got something like this. So now the discriminant is 0. So that b squared minus 4ac, you simplified that and got 0. The thing is, square root of 0 is 0. So we have negative 12 plus or minus 0. Well, we can drop that off because that doesn't change our answer if we plus or minus 0. So really we have negative 12 divided by negative 8. So simplify that, and that simplifies to 3 over 2. So what you'll notice is this time we only have one answer here. So that's where the equal roots comes into play. The way we conceptualize this is there is two different answers here, but they're both 3 over 2. So they're equal to each other, unlike the other ones where we had two different answers that were unequal. But 3 over 2 is a real number, and it's also rational. It is in a fraction with integers, and 3 over 2 is equal to itself. And that'll be the case for any example you get where the discriminant is equal to 0. So let's go ahead and look at this last example where we have the discriminant is negative, less than 0. So that would be imaginary roots, or sometimes you'll hear these called complex roots. And that's kind of it for this column. We don't think about imaginary numbers being rational or irrational. That only is a thing for real numbers. So imaginary numbers don't have that sort of categorization. And I guess they would be unequal, but that's not really important. Just the important thing here is that if the discriminant is less than 0, it's negative, then you're going to get imaginary solutions. Let's look at an example like that quickly. So let's say you simplify your quadratic formula and you get this, negative 4 plus or minus square root of negative 4 over 2. For this example, you might be thinking, how do I take the square root of negative 4? As you know, numbers squared have to equal a positive value, right? If I have a negative number squared, that equals a positive number. And if you have a positive number squared, equals a positive number. So how do you square root a negative number? That's where imaginary numbers come into play. And you will learn about that more later in your math career, or maybe you've already learned a little bit about it, but we're not going to go too in depth on it here. All you need to know right now is that if the discriminant is negative, if it's less than 0, then you have imaginary or complex solutions. So first thing on Delta Math is you are given find the nature of the roots of roots given discriminant, and this is a timed assignment, and you have to figure out a certain number of them in a certain amount of time. So you have to first decide, is this positive, 0, negative, and if it's positive, then you have to decide, is it a perfect square or not. So this is a positive perfect square, so that means it's real, rational, unequal. If it's negative, then that means it's automatically imaginary. If it's 0, then that means they are real, rational, equal, right? So you just have to move through these. This is not a perfect square, it's positive, so this is real, irrational. So you just have to move through these and try to get the number that you need right in the right amount of time. So you want to make sure you are referencing your table for that. So what is the discriminant of this quadratic equation? Another type of problem here. Here we are just going to use the formula, b squared minus 4ac. So we just have to identify our a, b, and c values. So a is this invisible one out in front here. B is this invisible one out in front of the middle term. And c is just 2. Remember, a, b, and c are just the coefficients, not the x's, right? So a is just 1, b is just 1, c is 2. So b, 1 squared minus 4 times a is 1 times c is 2. 1 squared is 1. Negative 4 times 1 times 2 is negative 8. So in this case, we have 1 minus 8 is negative 7. So that's all you have to do for this problem. It just asks for the discriminant. So the discriminant would be negative 7, but also good to connect this back to the other type and determine what kind of roots these are. So since this is a negative discriminant, these would be imaginary roots. So let's go ahead and look at one last example here. This time, the only difference is we have to get it in standard form first. So I think what I'm going to do is subtract the 8x squared on both sides. So you have negative 1x squared plus 14x minus 16 equals 6x. And then subtract the 6x on both sides. 14x minus 6x is 8x. So now we have it in standard form. So our a value is coefficient out in front, negative 1. B value is 8. C value is negative 16. So in our formula, we have b squared. B is 8, so 8 squared minus 4 times negative 1 times c is negative 6. So we got to be careful about our negatives. First thing, 8 squared is 64. And then we have negative 4 times negative 1 times negative 6. So that is going to be a negative times a negative times a negative, which is negative, right? So negative 4 times negative 1 is positive 4. And then positive 4 times negative 6 is negative 24. So 64 minus 24 is 40. So that's our discriminant. And 40 is not a perfect square. So this would be real, irrational, and unequal. All right. So that is all we have today for discriminant. If you have any questions about this, make sure you are asking your teacher, going to office hours, asking for help in class. and have a good day.